Hello guys, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve this problem from Fluid Mechanics by R.C. Hibbeler. The problem says that the tank contains air at temperature 15 degrees C and an absolute pressure of 210 kilopascal. If the volume of the tank is 5 meter cube and the temperature rises to 30 degrees C, determine the mass of air that must be removed from the tank to maintain the same pressure. So we can say that before and after the pressure remains the same. So P1 is equal to P2 is equal to 210 kilopascal. So 210 kilo will be 210 into 10 raised to the power 3 Pascal, or we can say 210 into 10 raised to the power 3 Pascal is Newton per meter square. Since the gas constant is 286.9 joule per kg Kelvin, so we must write the pressure units in SI units as well, right? So Pascal is the SI unit, which is Newton meter per second, but we have to remove the kilo, right? So this is 10 raised to power 3. Now initially it is said that the volume initially when the temperature is 15 degrees C, volume is V1 and that is equal to 5 meter cube. We can say that V1 at T1 equal to 15 degrees C. So we need to convert this T1 into Kelvin. Since this gas constant, we are using this gas constant in Kelvins. So we must write this T1 in Kelvins. So T1 is equal to 15 degrees C plus 273 Kelvin. So this will be converted into Kelvin. So 15 plus 273 is 288, right? So T1 is equal to 288 Kelvin. From gas law, we can say that P1 is equal to, we can say that P is equal to rho RT. So if you are considering the initial state, then this will be P1 and rho 1 and T1. And similarly, we know that rho, the density will be equal to, at state 1, it will be M1 divided by V1. So we can say that this will be equal to P1 is equal to, instead of rho 1, we can write that this will be M1 R T1 divided by V1. So from this equation we can find the mass. Since the problem says that determine the mass of air that must be removed from the tank. So we need to have the mass difference. So we need to have delta M, which is equal to M1 minus M2. So we have to find the mass difference to have that same pressure. So we can say that this will be, from this equation we can say that M1 will be equal to P1 into V1 divided by R into T1. So we can say that M1, now the pressure is 210 into 10 raised to power 3. V1 is 5 meter cube divided by R. R is 286.9 into T1. So T1 is 288. So this will give us the initial mass in the tank. 210 into 10 raised to the power 3 into 5 divided by 286.9 multiplied by 288. This gives me M1 equals to 12.708 approximately. This will be in kgs. Since we have used all the units in SI, so this will be in kgs as well. So if you guys are not sure about the units, right, so we can say that M1, the units of this is the pressure, right? So this is Newton per meter square. So this is Newton per meter square. And this term is the volume. So volume is meter cube divided by, this is the gas constant, which is joule per kg Kelvin, multiplied by T1. This is T1, which is temperature. So T1 is in Kelvin as well. Now you guys can see Kelvin cancel out with Kelvin, meter square cancel out with meter cube, and we know that joule, this is the unit of the work done, right? So joule, we can say that the work done is force times D. So this is equal to force times D is Newton meter, and Newton meter is equal to joules, right? So we can replace this joules with Newton meter. So this is equal to, we can say that this is Newton meter. So now this Newton cancels out with this one M cancel out with this, and we are only left with 1 divided by 1 over kg. And if we rearrange this, then we got the units of kg for the mass. So this is how we get the mass in terms of kg. So m1 is equal to 12.708 kg. Similarly, for the same pressure, since P1 is equal to P2, we want to find the mass, right? So the temperature has increased. So if the temperature has increased, so we need to remove some mass to maintain that same pressure, right? So we can say that for state 2, this is for state 1, when temperature was 15 degrees C. Now the state 2 is when temperature is 30 degrees C. So now if temperature is 30 degrees C, T2, we can say that T2 is equal to, that is 30 plus 273. So 30 plus 273, this gives us 303 kelvins. And we can say P1 is equal to P2, since we want to maintain the same pressure. So P1 is equal to P2. And we can say that now P2 will be equal to rho 2 R into T2. And similarly, again, we can say that rho 2 is M2 divided by V2 and R into T2, right? So now the tank has one constant volume, right? If the volume of the tank is 5 meter cube, so V1 is equal to V2 as well, right? The volume remains the same. So we can say that V1 is equal to V2. So we can say, if we rearrange this, then M2 is equal to P2 V2 divided by R T2. Now P2 is equal to P1 is equal to 210 into 10 raised to the power 3. V2 is 5 meter cube. R is 286.9 into T2. So T2 is 303 kelvins. So 210 into 10 raised to the power 3 multiply by 5 divided by 286.9 divided by 303. Multiply by 303. This gives me 12.2 is equal to 12.078, or we can say 0.709 approximately. If you want to if you want to keep that same pressure, we have to remove some mass, right? So the change in mass is M1 minus M2. So M1 is 12.708, M2 is 12.079, delta M is equal to 12.708 minus 12.079. This gives me 0.629 kg. So if we have the tank with a constant volume, if we have the tank with a volume of 5 meter cube, and if we raise the temperature by 15 degrees C, the initial temperature was 15 degrees C and the final temperature was 30 degrees C. So if we raise the temperature of the tank with a volume of 5 meter cube by 15 degrees C, we need to remove this much of mass, 0.629 kg, in order to keep that same pressure, which is 210 kilopascal. As you guys can see from this relationship, that the pressure and temperature has the direct relation. So P1 is directly related to T1. So if we increase the temperature of the tank, what will happen is that the pressure will increase. But if we want to keep the same pressure, what we need to do is that we need to reduce the mass. Because in this equation, if we look for this equation, this is P is equal to M1 divided by V1 R into T1. So if we look into this equation, this is equal to, let's say, M divided by V R into T. This is the generic equation. So if the temperature increases, then the pressure increases. But we want to keep the pressure same for the same volume. So this R is constant, V is constant, right? So we can say that P R divided by V M into T. So this is constant. We can say that P is constant into M into T. Or we can say that P is directly proportional to mass times T. So now if we increase the temperature, the pressure increases. But we want to keep the same pressure. So for that, if we increase the temperature, we have to reduce the mass. To keep the same pressure, we need to reduce the mass by 0.629 kg. So initially the mass was 12.708. So if you want to keep the same pressure, we need to have this much mass in the tank. So this is the solution of this particular problem. I hope this discussion will help you in the understanding of this problem.